Hello and welcome to this episode of Apps TV. I'm Peter Vaughan, one of the applications engineers here at Power Integrations, and today I'll be showing you how to bring up a power supply for the first time. So let's get started. Before I actually power up the power supply, what I need to do here is add a jumper on the back side of the PC board so we can monitor the drain current. And if you haven't already gone and purchased a current probe, I'd highly recommend it. It's an essential tool when you're testing power supplies. So I've got here a small cordless drill, and what I'm going to do is just cut the PC trace on the back of the board. Okay, that should do it. So now what I'm going to do, let me turn this off, is actually solder on the jumper so that we can hook in a current probe. Now I've cut this trace at the drain pin and not at the transformer pin, so that this current loop will only give us the drain current and not the current in the primary of the transformer, which will also include the current that goes into the clamp network. Okay, so that's good. Now that we've got the current loop attached, we're almost ready to connect up the scope probe and current probe and actually power this board up. But before we do that, there's one more thing I need to do, which strangely involves using a pair of cutters. And what I'm doing here is I'm cutting the undervoltage resistor out of the circuit. And what that does is it means that when we apply AC, the power supply, and the tiny switch 3 in this case, will immediately start to switch, which is useful because we want to see if the power supply is going to operate normally without having to wait for the input voltage to reach 100 volts or wherever the undervoltage threshold has been set to. Okay, now we've got the undervoltage resistor removed from the circuit, we're ready to connect up the scope probe and current probe. So I'm going to put the ground clip of the scope probe to basically the source pin connected copper area of the tiny switch 3, and then the scope probe clip goes onto the drain pin. So I could have connected it to the drain pin here, but as the drain pin also goes to this clamp diode, I'm going to hook it on here. It's just a little bit more convenient. And then the current probe is going to go through the loop that we soldered on earlier. You can see the current probe has an arrow on it, so I need to make sure that points towards the drain of the device. And then finally, I'm going to connect my AC input and I'm going to connect my DC load here to the output. Now we're almost ready to actually apply AC power. My preferred way of powering up the supply is to start with the AC variac set to 0 and then gradually increase the input voltage while monitoring the power, the input power on the power meter up here, and also the scope waveforms. Okay, so let me turn on the variac and very slowly increase the input voltage. The power meter is reading 18 volts and it's saying the input power is 25 milliwatts. And here we see at the top we have the drain voltage, and on the bottom we have the drain current. And what I'm particularly looking for is that we see a positive excursion on the drain voltage, and we can see the drain current ramping during the on time of the MOSFET. And approximately every 2 seconds the power supply is trying to start, which is why we see a switching pattern appear in both the drain voltage and drain current. So having seen this, I now feel more confident to continue to increase the input voltage. So I'm going to go to say about 40 volts, and let me apply some load now, turn this on. We see that when the MOSFET turns on, the drain voltage falls to 0, and simultaneously you see a linear ramp through the drain of the MOSFET and also the primary of the transformer. When the internal MOSFET turns off, we have a flyback pulse which delivers energy to the output. Once the energy has been exhausted, we see the relaxation ring, which is simply the residual energy in the core ringing between the capacitance and the primary inductance. So this is a very normal waveforms. I feel very confident to now turn it up to its minimum rated voltage of 85 volts and continue to increase the load all the way up to the power supply rating of 1 amp. Here the power supply is in regulation and operating normally. So I'll just briefly stop the oscilloscope. You can see that we have a series of switching waveforms, but if you notice here, one has actually been skipped. And this is how Tiny Switch 3 maintains output regulation, by enabling or disabling switching cycles based on the load requirements on the output of the supply. So there we have it. So that's it for this episode of Apps TV. I hope you found today's subject on bringing up power supplies for the first time useful. And please be sure to check back to our website for future episodes. Thanks very much.